If you need some tutoring in specific areas, but the tutoring businesses you've called only offer their services as a complete tutoring package, maybe Dr. John Tutoring is a better fit for you. Comparison of the power rule for derivatives and antiderivatives. Hi, I'm Dr. Grossman, and there's our power functions. For most of us early on in calculus, even if all the proofs make sense and we do all our homework problems, after just a few 24 hours away from the books, we tend to forget some of our rules of differentiation and integration. In general, the antiderivatives are trickier to do and usually easier to forget. Although it's true, as our teachers have told us, we should always check our antiderivatives by taking their derivatives. But on a test or when we're trying to follow the flow of a lecture, this may not be practical or possible. So mnemonic devices should be at our disposal. So why review the power rules? Well, they're often used in calculus, and other methods of integration actually try to reframe more difficult functions with the hope that maybe the power rule can be applied. Examples are integration by substitution and parts. Now I want to distinguish between a power function and an exponential function, because a lot of students early on get those confused. Now a power function is a function where the variable is the base and the exponent is a constant real number n. And an exponential function is where the variable is the exponent and the base is a constant number. Now sometimes it's good to learn simple things deeply. For example, let's go over the inverse operations, because it's going to take me to a place I want to bring your attention for the mnemonic that I'd like to share with you. Inverse operations, some examples here are multiplication, division, addition, subtraction, and also differentiation and antidifferentiation are inverse operations of each other. Antidifferentiation also is known as integration. Now, inverse functions, not inverse operations, but inverse functions, let's take a look at those a minute. Let's take the simple linear equation 3x minus 1. And we know that the first thing we do, if this is a mathematical sentence, is we're going to first multiply our variable x by 3. And then our second thing we're going to do is subtract by 1. Now if we take the inverse of the 3x minus 1 equation, which I assume that most of you watching know how to do, that we're going to get the equation x plus 1 over 3. And notice that when we take the inverse function of 3x minus 1, that the first thing we do now is we add 1. And the second thing we do is we divide by 3. So we have inverse operations in our inverse functions, and notice that they're in reverse order. In the equation on the left, we multiply first and we subtract second. In the equation on the right, we add first and divide second. Key points. 1. The inverse functions will employ inverse operations, plus they do so in reverse order. 2. The power rules employ inverse operations, plus they do so in the reverse order. And 3. You only have to remember the power rule for differentiation in order to recall the power rule for integration. That is, if you remember point 2, that the power rules employ inverse operations, plus they do so in the reverse order. So now let's do a head-to-head comparison of the power rule applied for differentiation and integration. Notice that we have power functions where the constant number is in the exponent. So with differentiation, what we do is, the first thing we do is we take our original exponent n and we turn it into a coefficient. And then we also take the original exponent and subtract 1. That's the second step. With integration, the first step that we do is we take the original exponent and we simply add 1. Then we take that same n plus 1 exponent and divide by that number. Don't forget when you're doing integration that you always have to add the constant of integration. Very easy to forget. Okay, now let's go to the next slide and do a head-to-head comparison focusing on the order of operations. So in the first equation at the top, what we had was the first thing we did with n was we multiplied. And the second thing we did was subtract. Down here in the integration, the first thing we did was we added. And the second thing we did was we divided. Okay. So let's take a problem with an actual number in it. Doing our differentiation, we'll take our original exponent, which is 4, and then subtract 1 from the exponent, so that comes out to be 4x to the third. In our differentiation problem, what we do is we add 1 to the original exponent and then divide by that number. So that answer is going to be x to the fifth divided by 5 plus our constant of integration. Okay, now there is one exception for the power rule for integration, and that is when n is equal to -1. And you'll notice up at the top here where if we put -1 into the equation, the answer is going to be x to the 0 over 0, and that is not a kosher answer. So the answer to this one exception for the antiderivative of x to the -1 with respect to x is the natural logarithm of the absolute power of x plus the constant of integration. And this is beyond the scope of this little review here, but be sure to look this up if it doesn't strike you as familiar. Okay, now let's do one more example, and just a little bit harder. I'm not giving very hard problems here. My main point of doing this review is to show you the mnemonic of how to remember the power rule for integration. So in our first equation with differentiation here is x to the 7/3 power. So the first thing we do with differentiation is we take the original exponent, which is 7/3, bring it to the front, and now we've got 7/3 that we're going to subtract 1. Now, since this is a fraction in the exponent, we're going to subtract 3/3. That's the same as 1. So our answer is going to be 7/3 x to the 4/3 power. And you could rewrite this as 7x to the 4/3 over 3 if you wanted. And that's our answer. So even with something as seemingly complicated as a fraction in our exponent, doing the differentiation power rule is just really not that hard. And you probably will remember it weeks from the time you learned it. But for some reason, integration's a little bit harder. So let's do the integration for the same problem using the power rule. Now the first thing we do with integration is what was the second thing we did with differentiation. And what did we do second with differentiation is we subtracted 1. So the first thing we're going to do with integration is the inverse operation of that. We're going to take 7/3 and we're going to add 1, which is 3/3, same thing. And what was the first thing that we did with differentiation? The first thing we did was we multiplied the original exponent. So that means the first thing that we do with differentiation is the second thing we do to integration, and it's going to be the inverse operation. So the second thing we do is division, which here is going to be 10/3. Now we can clean this up, and the top could be x to the 10/3, and that's over 10/3, and then we can clean that up even further, and we can invert and multiply. So that's going to be 3/10 x to the 10/3. We can bring that over, and that's plus c. Okay. Now let's go and just do a summary here. The summary is, if you can't recall the power rule for integration, then draw on your knowledge of the power rule for differentiation with 3 steps. Step 1 is just remind yourself that you're going to say, I need inverse operations in reverse order from the power rule for differentiation. Okay, that's just to orient you, remind you. Step 2 is ask yourself this question: what do I do second in differentiation when I'm doing the power rule? And the answer to that is I subtract 1. Now that's just something that most people find easy to remember. So if I subtract 1 second in differentiation, that means the first thing I do in integration is I add 1 to the exponent. Now step 3 is you ask yourself, what do I do first in differentiation? And the answer to that is you multiply it by the original exponent. So that means the second thing you do in integration using the power rule is you do division by the new exponent. Remember, you multiplied by the original exponent first in differentiation, and so the second thing you do in integration is you divide by the new exponent. Now this mnemonic may seem ridiculously simple to people that are math majors or have been doing calculus a long time, and it may be confusing to people who are just starting out. I don't know, but I have found that it's been helpful for me, and maybe there's a few of you all have found this to be useful, and I hope so. And that's it. Thank you.